Okay, so moving on to example 3, we want to find the inverse of the function f of x is equal to x squared when x is greater than or equal to 0. Okay, so our very first step, what we're going to do is we're going to rewrite my original with y instead of f of x. So I get y squared is equal to x squared. So this is still my original. And so my step 1, just like I did in the previous examples, is to swap my x and y values. So if I swap them, I get x is equal to y squared. Step 2 is solving for y. So since I'm squaring y here, I want to square root both sides. When I square root, the square and square root cancel out, so I get y is equal to plus or minus square root of x. I know my x values can only be positive in order for them to be real numbers. But just like I was saying before, in order for this to be a function, just like I talked about the graph over here, my orange graph, it doesn't pass my vertical line test. So in order for it to pass, I actually have to cut off the other half of my quadratic, or my sideways quadratic. So I'm going to take off the negative, so my answer should be y is equal to positive. Square root of x is my answer, and that's example 3. Just like I was saying, for your inverse to be able to pass, your vertical line test in order for it to be a function, we also have what we call the horizontal line test. Your horizontal line test tells you whether or not your original function will have an inverse that is also a function. So for example, I'm going to use the exact same example I did before on the other page. This is my original function, which we'll actually highlight in the blue. If I flip both sides across just like this guy, in the orange, if I flip him across my y equals x line, I know that my orange graph does not pass my vertical line test. But every single time I don't have to flip it over graphically. I can check to see if it passes my horizontal line test. And if it passes my horizontal line test, I know my inverse will be a function. So in this case, because my inverse does not pass my horizontal line test, I know that if we call this g of x, that g of x, the inverse to g of x, will not be a function, because it doesn't pass my horizontal line test. And my horizontal line test is very much like taking my inverse and trying to pass my vertical line test. So if your original does not pass your horizontal line test, its inverse will not be a function. So let's call this guy over here, this is going to be my cubic function, we'll call him f of x. So if I take f of x and I take my horizontal lines and I pass it all the way straight through, your inverse, because it passes your horizontal line test, since it passes it, which means that at any given point it only intersects my graph at one particular point per horizontal line, its inverse is a function. So that's something that's going to be important to remember, just to help you out and save yourself time from having to graph both of them. So looking at example 4, find the inverse function. So let's consider y equals 1/2 x cubed minus 2 is our function. We want to determine whether or not its inverse is a function, and we also want to find its inverse. Well, the first is, if I were to graph this, I know I have a cubic function. So I know for a fact that its inverse is probably going to pass the horizontal line test, which means its inverse is going to be a function. But let's start off by determining whether or not the inverse, we have to first find the inverse to determine if it's going to be a function. So I'm going to take my f of x and replace it with y. So this is my original. Step 2, I'm going to swap my x's and y's around. And then I'm going to solve for your y. So I want to solve for y all by itself. So I'm going to first add 2 to both sides. When I do that, I get x plus 2 is equal to 1/2 y cubed. To get rid of the fraction, we know we can multiply both sides by its reciprocal. which is 2. And multiply both sides by the reciprocal, which is 2. Since this whole side is getting multiplied by 2, I have to distribute the 2 to both terms on the inside. And then lastly, because it's y cubed, I have to cube root this entire inverse, or this whole side on the left. So if I cube root, because cubes and cube roots are opposite of each other, I get y is equal to the cube root of 2x plus 4. And since its original graph was a cubic function, I know that its inverse is going to be a function. So this is going to be, yes, I know it's going to be a function because it passes my horizontal line test. And to find the inverse, my inverse, and I can also write it like this just because I know it's a function, my inverse function, so f to the negative 1 of x, is equal to the cube root of 2x plus 4. Alright, that's example 4. Making sure that you have all your group warm-ups finished, the rest of this packet finished. We'll meet at our next class to go over any questions that you have. So if you do have questions that can't wait till then, feel free to email me. Otherwise, we'll meet during our next class and go over your questions for this and do an in-class assignment together in groups. Alright, see you then.